Hello, fellow YouTubers and my loyal followers. It has been a while since providing you with an update on this 3D printing channel. I'm going to seize the occasion, in the lingo of my new YouTube channel motto, to talk to you about my latest printing project. But please excuse the artificial background going on behind me. But if you are an avid do-it-yourself or have a 3D printer and are proficient at modeling software, this might be just the video for you. So this is going to be a generalized look at the process I use to solve a drain stopper issue. The fixture in this bathroom has a push-pull plunger and a lever action stopper mechanism. But because of interfering pipe underneath, the action was always too stiff and barely opened the drain. And hence we resorted to using a rubber band to hold the drain stopper open. Admittedly, this was a less than perfect but intermediate solution. I imagined it would be within my level of expertise to create a couple of cylindrically shaped articulating PLA parts with holes so positioned to allow drain water to pass when turned so that the holes aligned with one another. Then, when the parts were rotated with one's fingers, some holes would become blocked and the sink could hold water. Then, when rotated back, the sink would drain. It would look better and it would work far better than a rubber band. To start off my projects, I always start with a sketch on paper or in Microsoft Paint. I might add a photo as a reference. And this is where I work out in my mind any potential issues, like what material will I use to print, how much tolerance will the articulating parts require, design considerations like will thumb flanges be necessary. Once the details were fleshed out, I took measurements. I actually had to eyeball drain's diameter because my rigid ruler and the curved sink bottom wouldn't easily allow an accurate measurement. But I was lucky, however, to get close enough on my first try. Now, the diameter of the existing plug was easier, as I could use the digital measuring calipers there. And then I transferred these initial critical measurements to my rough sketch, and with these I calculated the remaining measurements necessary to model the initial lower cylinder that fits into the drain. Using the non-commercial version of Fusion 360, I created a sketch. Using the timeline, I'll present each of the steps to arrive at what you're seeing here, the finished model. I used the center circle tool starting on the center point of the XY plane. I supplied a circle diameter equal to that of a snug fit of the bottom cylinder's outer diameter to the sink drain wall. And then using the offset tool, I supplied a negative value, that of it being equal to the thickness of the intended cylinder's wall. And then from there, I used the push-pull tool to change this two-dimensional sketch into a solid shape. And it was given a minimum height just so that I could test the fit of the drain and also the accuracy of my measurements. Here I can make a couple of test prints, and I can make sure that the lower cylinder would fit directly into the drain without a problem. And I can also make sure that the measurements for the lower cylinder's openings are correct, that they will allow water to drain from the sink bowl. Advancing forward to the next step on the timeline, the vertical XZ plane was used to sketch the shape of the openings on the lower piece. And by combining circles and lines, I formed the desired shape. Here you can see that the sketch surface is on the XZ plane, passing through the center point of the model. The cut operation on the push-pull tool makes the desired hole in the cylinder. The pattern tool makes it easy to replicate the hole 3 more times. So that the components in the assembly can be manipulated separately on the print bed, and so the joint feature can later be used to demonstrate how they move. A new component for the outer stopper part is created. Catching up, a new sketch was created, supplying dimensions for the new outer stopper. Using the push-pull tool again, transforming the sketch to 3D. Sketching again on the XZ plane, the vertical slats that allow passing the drain water. Rotating the model in Fusion 360 is great for checking the progress from all angles. I should note here that using the distance parameter of the push-pull tool was required here, as the group of extrusions wouldn't all intersect the cylinder wall within the same plane. The circular pattern tool gets involved here again to replicate the groups of horizontal filtering slats. A tangent plane is created, and with an offset is used to model up the plug's first handle. Push-pull tool used to form the roughly shaped handle protruding from the outer stopper part. Rolling the timeline forward, We view the second handle being made from the circular pattern tool. Fillets are applied to the handle's edges and corners. One of the two pieces must be grounded to use the joint feature. Back again to the finished assembly, seeing the working circular joint in action. Here we have it. Hopefully, seeing these steps has helped you in some way. Perhaps this will inspire you in one of your own do-it-yourself projects. If you find something useful here, please consider clicking on the like button or leave a comment. You can see other videos I've produced by following the links that you see. Meanwhile, seize every moment and make your day count. Until next time, take care. Good luck.